Hello, let's go on to our next calculus problem. A woman at point A on the shore of a circular lake with radius 2 miles wants to arrive at the point C diametrically opposite A on the other side of the lake in the shortest possible time. She can walk at the rate of 4 miles per hour and row a boat at 2 miles per hour. How should she proceed? So, of course, it's natural that you'd be faster along the arc of the circle because you'd be on ground as opposed to rowing a boat. So you'd be slower there, 2 miles per hour. A and C are on opposite sides of a particular diameter. So for the two figures you see here, I didn't see any need to draw the entire circle. Now, the woman has two extreme options. She could walk around the half circle, the semicircle, or she could row straight from A to C. Rowing straight from A to C would provide the shortest possible distance, but then she'd be slowest if she would be rowing all the way through. So maybe there's a point B somewhere along the arc where she could divide her journey into strolling along the arc or going straight on the water itself. Now, even with such an intermediate point B, there are two options. Does she walk first and then row? Or, as in the second figure, does she row first and then walk along the arc? Well, because you could interchange these two scenarios, let's just choose one of them. So for this problem, let's assume she's going to walk along arc AB first, and then she would row straight on to on segment BC. So let's assume that. What we want to do is, how should she proceed? Find the location of point B so that she would consume the least amount of time. So when it comes to distance, rate, and time problems, then the formula that would be most useful to us is the usual formula. Let me write it here. That the time is equal to distance covered over the rate. So distance equals rate times the time. Now, so the rates are given, 4 miles per hour and 2 miles per hour. So that means we need to figure out the length of the arc on AB and then the length of the segment BC. So one thing that's going to help us here is to um, connect B and the center of the circle of radius 2, and then the location of point B, instead of letting that be x, I'm thinking of assigning a variable to the angular opening here, theta, because then we should be able to determine the lengths that we need, the ones in yellow and then blue-violet in terms of theta. We know that the answer is going to be in terms of theta because the opening of this angle determines where B is, and so once you've identified B, then you should be able to determine how long the arc AB is and the segment BC is. One of the formulas that would help us from high school trigonometry is this fact that if you have a sector with angle theta and with radius r, then the length of this arc along a circle, they're all going to be related to each other by the following formula: S is equal to r theta. And so therefore, for this problem, what we see is that the length of arc AB is equal to the radius 2 multiplied by the angle theta. Now to figure out the length of BC, which is the side of a triangle, so I'd like you to look at this triangle with side BC, and then with this radial segment, and then with this other radial segment that's forming that triangle. What we're going to do is we're going to use the law of cosines. BC squared equals the length of one side, this side, squared, so you have 2 squared, plus the length of the other side, this side, squared. So again, you have 2 squared minus 2 times the product of the two adjacent sides, 2 and also 2. They're the same because they're radii, multiplied by the cosine of this angle, all right, opposite BC. Now, this angle is supplementary to the angle theta that we already have here, so this is going to be pi minus theta, or if you want 180 degrees minus theta, so cosine of pi minus that. So therefore BC squared is equal to 2 squared plus 2 squared, we have 4. No, sorry, actually let's just make it 8, because it's 4 plus 4. So this is 8. Minus 2 times 2 times 2, so that's going to be 8. And then cosine of pi minus theta by properties of trigonometric functions, that's negative of the cosine of theta, because pi minus theta and theta are supplementary to each other, so therefore their cosines are negative. So that's going to require us to turn this into plus. So therefore BC is the square root of that. And going back to the formula that time is equal to distance over r, the total time is equal to the time along arc AB plus the time along BC. And then each of those times is equal to the distance covered over the rate. So therefore, the time big T as a function of theta equals distance over rate. For arc AB, that's a distance of 2 theta, and then the rate of walking is 4. Plus, next up, distance BC, so that's the square root of 8 plus 8 cosine theta divided by the rate, which is 2 miles per hour. We can clean this up a bit. You have theta over 2, and then in the numerator you have 8 as a common factor of the two terms. You could take that out in the square root, so you have 2 square root of 2, and then the square root of 1 plus cosine theta divided by 2. So all you really just gotta do here is cancel the 2's here, and then this one, then you pretty much have t of theta. Now, as for the domain, the allowable values of theta, if you look at this figure, theta can be 0. You can imagine what would happen if theta is 0. That would mean you don't have this visible angle opening, so that would mean B would be right exactly where A is, which means that you don't get to walk on any arc. This means you would, in this case, be rowing straight from A to C. On the other hand, when theta is gonna span the entire semicircle, so that would mean the protagonist of the story would be walking along the entire arc of the semicircle from A to C, so there would be no part where you would be rowing. So these are the two extreme situations. So theta is from 0 to pi with both endpoints included. So yeah, that's our domain. So the domain of domain of t is equal to the interval from 0 to pi, which means that we could use the extreme value theorem here. I just realized in my solution to problem number 3, I said absolute value theorem. I meant extreme value theorem. Oops. So after we find the critical numbers, we can evaluate t at the critical numbers which survive, and also at the endpoint 0 and pi, and we're looking for the smallest possible output. So what you can do is you can stop here, pause the YouTube video, and then try to find the critical numbers on your own. So you can do that. And then just like after you're done with it or you're stuck, you can play the video again. Alright, so stop. Okay, so in case you did stop, let's continue and verify whether you got the same thing. So t prime of theta. T prime of theta, so you have the derivative. So theta is our independent variable here. You have 1/2. And then for the next term, you still have the square root of 2. That's just a constant. So it's really this radical that we have to differentiate. You have the exponent 1/2, so that would then go down. So you would have 1/2, and then you would then have this 1 plus cosine theta, now raised to negative 1/2. So that would go down as this radical in the denominator, 1 plus the cosine of theta. And then the numerator would be the derivative of 1 plus cosine theta, so that would be negative sine of theta. Now, let's start with critical numbers of the second type, where the derivative would be undefined. So if t prime of theta is undefined, that's going to happen when the denominator you see there is 0. So that would be when you have 1 plus cosine theta equals 0. And that would mean cosine theta equals negative 1. So you're in the unit circle, the x-coordinate is negative 1. That's going to happen when theta is 180 degrees, if you imagine it. So theta is equal to pi. So even if you didn't end up with this, well, you would still have had to evaluate t at one of the endpoints for an interval, which is pi. Now next, when would t prime of theta be equal to 0? So that's going to happen if you solve this equation. So you have 1/2 okay, minus sine of theta with the square root of 2 over 2 square root of 1 plus cosine theta equals 0. I realize this would be the more challenging part of the problem, solving this trigonometric equation. Now, this would mean that, okay, because normally I wouldn't do this, but I have 15 minutes for this video, otherwise I'm going to have problems uploading this, so you could cancel out the 2's. So then you're going to have the following. 1 is equal to square root of 2 sine theta over the square root of 1 plus the cosine of theta. So therefore, the numerator and denominator are the same. So you have the square root of 1 plus cosine theta is equal to the square root of 2 sine theta. So many radicals there, so let's square both sides. You have 1 plus the cosine of theta, and then here you have 2. And then sine squared, which I'm going to rewrite as 1 minus cosine squared of theta. So then you're going to see that both of these two sides have 1 plus cosine theta as a factor. So if you cancel 1 plus cosine theta, you have 1 here, and then 2, and you'd still be left with 1 minus cosine of theta. Okay, just to be clear, I was assuming there that 1 plus cosine theta could be used as a denominator, and that would assume that 1 plus cosine theta was 0, but what if 1 plus cosine theta was actually 0, but then that was already something that we catered to above. What if 1 plus cosine theta is equal to 0? So you can see that here. Alright, so if 1 plus cosine theta is 0, you would have theta equal to pi, but already something that we've already considered. So assuming this, then that means cosine theta, you could algebra your way through this, cosine theta would be 1/2. Then what's going to happen is then over the interval 0 to pi, theta is equal to pi over 3. So then evaluate t at 0, t at pi, and t at pi over 3. And you would then find, okay, because I'm running out of time, the values are here, approximate to 2 decimal places. 2, and then t of pi is 1.57, and then this is 2.26. So assuming I did the calculations correctly, you would have the least time here. All right. Gotta stop this video. Make sure you answer the actual question. Bye bye.